Now, as we stated before, this is the only module in Unit 9, ANOVA, because this is all we're going to do as far as ANOVA goes. We're not going to get deeper into it because it's too complicated for this class. So this is the end of Unit 9. We'll summarize everything we've learned in this one module, which is the entirety of this unit. First, we use the ANOVA F-test when we compare more than two population means. We can also think of the ANOVA F-test as a way to determine the relationship between a categorical explanatory variable that has more than two values and a quantitative response variable, like the examples we've seen in this module. The hypotheses that are being tested in the ANOVA F-test are: the null hypothesis is that all the mu's are equal. No matter how many populations you're looking at, the mean is the same for all of them. The alternative hypothesis, on the other hand, is that they're not all equal. Maybe all but one are equal, but there's at least one that's not the same as the rest. Alternatively, we can state the null hypothesis as there is no relationship between the explanatory and response variables. And the alternative hypothesis is that there is a relationship between the explanatory and response variables, like in that example we just saw about major. So the null hypothesis would say that there is no relationship between your major and your frustration level, that no matter what your major is, at least of those four majors we looked at, it shouldn't matter that your mean frustration level is the same. That's the null hypothesis, but the alternative hypothesis would be that there's at least one of those majors that the average frustration level is a little higher or a little lower. We don't know, but it's not the same as the rest. Now, we also check the conditions for the ANOVA F-test. This is important. It's almost the same, but there's one extra condition. First, the samples are randomly selected and independent. That's the same condition we've seen before in previous modules where we have only two mu's that we're comparing. Also, the distribution for the response variable in each population is normal in shape. If we can't verify this, we examine the distribution of the response variable in each sample. If the sample distributions are not heavily skewed, then we assume that the response variable is normally distributed in each population. So that's the same as before, but the only thing that's new for the ANOVA F-test as opposed to the p-values and the z-scores is, oh, sorry, not p-values, the t-scores and the z-scores, sorry. The standard deviation of these response variables in each population is the same. If we cannot verify this, we compare the sample standard deviations. If the ratio of the largest to the smallest sample standard deviation is less than 2, we just divide the largest by the smallest. If you get something greater than 2, then you can't use the ANOVA F-test. But if you get something less than 2, like we saw in the previous examples in this module, we assume that the standard deviation in the populations is the same, basically. If it's less than 2, maybe the difference might just be due to chance instead of due to actual differences. Also, the idea behind the ANOVA F-test is to check whether the variations among the sample means is due to true differences among the mu's or merely due to sampling variability. We use the F statistic, which is a ratio of the difference in sample means to the variation within each sample. The formula is basically looking like this, but there's a complicated formula we're not worried about in this class that actually calculates the F statistic, and we use technology to calculate it instead of calculating it by hand, like StatCrunch or something like that. Once we verify that we can safely proceed with the ANOVA F-test, we use StatCrunch or other software to carry it out. If the ANOVA F-test has rejected the null hypothesis, we can look at the confidence intervals for the population means to get a visual insight into why the null hypothesis was rejected. In other words, which of the means differs from the other.